problem number one. Well, our speaker today is not a guest. He is our Rotarian, Bhima Nitta. As you know, Bhima is the owner and operator of Power Guru in North Bennington, and he works all over the place. Every time you turn around, he's got a project going. Bhima is also very involved with our Citizen Action Committee in North Bennington and Shaftesbury. Hold on, I'm making noise. And Bhima is going to talk to us today about the technology behind
heat pumps.
Heat pumps, thank you. There goes my thing. But many of you may remember when Bhima did his classification talk and talked about the whole solar thing. I just thought it was fascinating, and I learned more about solar in that one talk, and in ways that I could understand than I think I have in a long while. So I always think it's fascinating and admirable when people can take a difficult subject and put it in words that the average person can understand. So that is what Bhima will be doing. Thank you, Bhima.
Thank you, Mary. No, I'm good. That's a big challenge. I'm not sure I can rise up to it, but we'll see. So when Mary first asked me to give the talk, I was a little confused. There were gentlemen here who can talk about heat pumps in greater detail and greater depth than I can. And I thought Mary had made a mistake, that instead of talking to Jerry, she talked to me, and now it's too late. And we look alike, we talk alike, right, Jerry? It's an easy mistake to make. Yeah, right, yeah. So anyway, yeah, so my background is I'm a PhD chemical engineer. I worked in United Technologies for many years designing fuel cells and combined heat and power systems, which are all part of the energy industry and which all feed into HVAC, which is where my interest in energy efficiency and all the technologies therein come in. And afterwards, I worked for Efficiency Vermont for I don't know how many years, 6, 7 years, seems like forever. But yeah, in that role, I incentivized people, I coaxed people, I cajoled, urged, threatened in many other ways, try to get them to be more energy efficient, try to do heat pumps. And so now I'm a solar installer, so I'm sort of, became a sort of a force of habit to try to get people to do heat pumps. No, but really, I think it's because we, we recognize that heat pumps are a crucial part of the technology as we move towards a low carbon or a no carbon source of energy. And plus, when I talk to folks about heat pumps and they install heat pumps, I do a bigger solar installation. So, so it all works out. So that's why I wanted to talk to you about heat pumps, or I can talk a little bit about heat pumps. And so the other question is, why are we talking about heat pumps in the first place? So, and I think you mentioned briefly, it's about the fact that there's now sort of a convergence of things going on. There's a huge environmental issues that we are facing as we transition from a carbon-intensive lifestyle to one where we live much lighter on the land. We try to transition towards a more electrical-based way of living. And so yeah, big picture, the energy ecosystem is changing in a pretty dramatic way, whether we like it or not, whether we understand it or not, whether we appreciate what's happening. Things are changing pretty dramatically. When people loosely talk about smart grid, Internet of Things, these all feed into it. We are trying to, GMP is working to make our own distribution infrastructure smarter in many ways, where you don't have to build so much distribution or so much generation to meet the energy needs of the people. And so where do heat pumps fit in? We know that heat pumps displace the use of fossil fuels. And so GMP is trying to encourage folks to install them, and they are getting into this business as well. So it all comes into the mix. So massive, large-scale electrification of all energy sources and things. So this convergence is, historically we have been using what? All fossil fuel based heating sources, right? I mean, you got your oil furnaces, your propane furnaces and boilers. They all burn fossil fuels. A good propane furnace is about 90-95% efficient. There's 91,000 BTUs per gallon in propane, 138,000 BTUs a gallon in oil. That's a lot of energy density. And where we are now is a result of, well, how far back do you want to go? 65 million years? And the dinosaurs went extinct and they didn't know that they were contributing their bodies towards us to burn, carbon fueled sources to heat our homes with and to transport ourselves all over the world with. So where we are now is we are transitioning away from that as we realize that burning these fossil fuels is generating all the carbon, which is heating up the atmosphere and so forth. So heat pumps save the environment and reduce your fossil fuel consumption or carbon footprint. And as I mentioned, we can meet the electric needs with solar. Heat pumps save you energy. They are more efficient in the use of the primary energy source than any other way of heating your home. Right? When you burn oil, and I'm going to go into the details a little bit. Heat pumps are about 3 or 4 times more efficient than any oil-fired furnace, 3 or 4 times more efficient than propane-fired furnaces, 2 to 3 times more efficient than electric resistance heating. So when you do the numbers, when you calculate out to how much oil you burn versus how much electricity you consume in the heat pump, it turns out you save a lot of money. And you save that money, and you're spending money to buy the heat pumps, and you look at the paybacks, they're very good. So I'll go through the calculation a little bit. So yeah, so that picture over there shows the heat pump right up there on the wall. It's an indoor unit, and you folks can come and beat me up if I'm wrong. It's about a foot in width, about 4 feet long. And the next picture, because I'm a sort of an engineer, I have to show this to you. Do I have to explain this to you? Maybe I will explain a little bit. If half of you leave the room, I know what's going on. So basically, you can start somewhere. It's basically a closed loop refrigerant process. People ask, how can heat pumps work? How can something that grab heat from the outside and put it into your room, and it's so cold outside in the winter, right? So I mean, think about this. That's how your refrigerators work. Your refrigerator takes heat from inside the cold box and puts it into the room. That's essentially the principle of a heat pump, right? So start anywhere in this closed loop process. That condenser, assume that's inside the room right now, right? That's that thing up on the wall. So you got a hot gas refrigerant vapor coming into the condenser, which is hotter than your room. And when the fan blows across it, it blows the heat into the room. The hot gas condenses and it becomes a warm liquid. So it goes through this expansion valve, which if you're an engineer, we call it a Joule-Thompson expansion, but basically it expands and becomes very, very cold. Much colder than outside, than the atmosphere out there. So then it goes into that evaporator which is outside, and because it's a lot colder than the outside, the evaporator is able to heat it up, heat up the vapor. So heat up the liquid. Now the hot liquid goes through the liquid goes through a compressor and gets heated up a lot more. The vapor goes through a compressor, gets heated up a lot more, and so it comes back into the room, and the cycle continues. Does that make sense? No?
But I get it.
Okay. So go ahead. Yeah, one of you raise. You go ahead, Ted.
You said something about a fan.
Yeah.
What powers the fan?
A variable speed drive. It's a very high efficiency motor coupled to a device that can slow the fan down rather than shut it off. Slow the fan down, and there's a law that says as you turn fans down, energy usage does not drop in proportion to how slow you turn the fan down. If you turn it down by 50%, energy usage becomes about 12%. So it's a very, very high efficiency fan that powers, that drives, that blows across the refrigerant and the condenser and the evaporator.
Fan does come from the grid.
From the electric, yep. So yeah, make no mistake, this is based on electricity. It runs off electricity. Unlike your propane or oil, there is no combustion involved. There's nothing being burned. It has to run on something, right? So according to the law of thermodynamics, if you look at, go back to your books, heat flows from a source of high temperature to a source of low temperature. If you want to move heat from something that's colder to something that's hotter, you need to put work into it. That's where the electricity comes in. If you put the work in, you can drive heat from cold to hot. That in a nutshell is how a heat pump works. If 10 people got this, I'll be happy. Go ahead.
What is it in the expansion valve that super cools that?
Yeah, so this goes back to some thermodynamic principles. It's called Joule-Thompson expansion. When you put something through a valve, as it goes through the valve, the gas expands as it comes out, and as it expands, it cools down. Right? So the entropy, there's something called entropy which is preserved, which means that it doesn't really lose heat to the outside, but whatever is contained in it has to be going towards another thing. So it changes as it cools down. It changes its state. It goes from vapor to a liquid. Sure.
If I give you the square footage of my house and the
Yep.
gallons I use of oil, can you give me an estimate?
Aha, you're coming to something that is about 4 slides down, but I can do that. It depends on how much your fuel consumption is, how tight your home is, and so forth. Efficiency Vermont has tools that that can help you figure out how big how much fuel you're consuming, what your heat load is on your home, and how big a heat pump you need. And I'll go through the calculation a little bit. So is that somewhere? Okay, so this is a picture of an air source heat pump. So what you have is this indoor unit, which is the evaporator I talked about, and then you have this outdoor unit, a condenser, right? In this case, there's one zone, one unit inside and one unit outside. So what you can have, and what Bennington Coolney Heating, many other heat pump companies sell, are also multi-zone units. You can have one outdoor unit with multiple indoor units. And because there are no ducts, the only thing connecting them is this refrigerant line, right? So because there are no ducts, they are called ductless mini splits, split system, multiple indoor, mini, small indoor units, right? So in this case, you're seeing that unit up on the wall. There are also units that are floor mounted. So if folks don't like to see those big white things up on the wall, they can have something that's close to floor as well. You folks can jump in anytime and say, Bhima, you don't know what you're talking about.
Well, 2 of us understand what you're saying.
Oh, great. Job done. I think I can go home now. Okay. So that's an air source heat pump. Conventional is also called cold climate heat pumps here in Vermont. And the next one, this is a ground source heat pump, also called a geothermal heat pump. So in this case, there's a ground loop, but there could also be a well, much like a water well that's dug, and you can have a shaft that goes down it with the exchanger at the bottom picking up heat. The great thing about ground source units is that they are considerably more efficient than air source heat pumps. Why is that? Bingo. So the ground is at a pretty steady, and once you go 3 or 4 feet down, the ground's at a pretty steady temperature of 50-55 degrees or so, as opposed to the ambient. So because of that, these guys can be about about 5 or 6 times more efficient than your propane fired furnaces and so forth, right? One thing I failed to point out, heat pumps can be used for, they are reversible, they can be used for heating and for air conditioning, right? And in their air conditioning mode, they are about 3 times more efficient than your hole in the wall air conditioner. Please, if you have that, get rid of it. That has, they have what's called seasonal energy efficiency ratio to tell you how efficient a unit is. Portable or these window air conditioners have a SEER rating of 9. These guys have a SEER rating of 23 or 24. So they're phenomenal. So okay. How am I doing? Okay. So we talked about air source, ground source, heat pumps. You can also, and I was talking to George the other day, you can also do radiant loop integration, which means you have a hydronic loop, you can integrate a heat pump to it. Unfortunately, they aren't for sale here in the US. It'd be lovely if you could do that. But I knew, are there units which are, I think you mentioned that commercial units could be integrated, right?
Yeah, they do have, Mitsubishi has the VRF systems that you can integrate with. And of course, they have the heat pump hot water heaters now that they're
Right, yeah.
well,
So
they're getting there, but they're just not available for hydronic systems yet.
Yeah. So watch this space. So you can have forced air you have forced air ducts. You can integrate. You can have a big heat pump there, which displaces your forced air propane unit or forced air oil unit. You'll have to change the ducts though, because you need to have a certain velocity of the air to carry the air into all these rooms, and they may not be sized to the same capacities as conventional furnaces are. So you may have to change the ducts in those. All right, so I promised you that I'll show you what the calculations look like. Numbers. Okay, so let's say that you have a home which consumes 1,000 gallons of oil, right? And the boiler has an efficiency of about 85%. The oil's heating value is about 138,000 BTUs or so, right? So you can estimate, based on that, you can say, okay, the home heating load is about 117 million BTUs a year. So I mentioned to you that heat pumps are about 3 times more efficient than conventional units. That measure is something called COP, coefficient of performance. What that means is, remember we were talking about, I think we were talking about the fans and the compressors that run on electricity. How much electricity do you have to put into a heat pump relative to how much heat that it delivers? To deliver 3 kilowatt hours worth of heat, which is about 10,000 BTUs worth of heat, you have to put in 1 kilowatt hour of electricity. So that's why it's, that's the COP, that's the, that's the measure of the efficiency of the unit. So the COP, that efficiency does not stay constant. It changes as the outdoor temperature varies. The warmer it is, the higher the efficiency is, to the point where when it's down to 5 degrees or so, or, I think basically if it's down into the 20s and so forth, its efficiency keeps dropping, and at some point it matches that of an electric resistance heater, right? So with an electric resistance heater, right, it's just a coil of wire, you plug it into the wall and you put, when it's running, if it consumes 1 kilowatt hour of electricity, it will give you 1 kilowatt hour of heat, right? That's how electric resistance heaters work. So coming back to furnaces, you put in, you burn 10,000 BTUs worth of oil, you only get 8,500 BTUs of heat out of it. The rest of it goes out the flue of the chimney, right? So that's what this calculation is saying. It's saying you have 1,000 gallons, you're burning 1,000 gallons of oil, you recover 85% of the thermal output of that 1,000 gallons. So that's how you're able to calculate the house heating load as being 170 million BTUs a year. The cold climate heat pump has a COP or a efficiency of 3. So its energy usage is going to be about 11,000 kilowatt hours of electricity. So I mean, this assumes that you can displace all the 1,000 gallons of oil, but in reality you cannot. You could probably displace about 75–80% of it. Why is that? Because as the heat pump goes down, it loses its capacity as well. As it goes down in temperature, as the ambient temperature drops below about 5 degrees or so, its capacity also drops. At some point, the heat pump itself shuts off. So you have to have a backup system. You cannot just rely on a heat pump. I take that back. I rely just on a heat pump. If you have a really tight, really well-insulated home, which is, conventionally, you can get there. I used to have a friend, Jim Gooden, I don't know if you folks know him, but he would say, I would insulate the X out of the home to the point where you can heat it with a candle. That's what he would want to say. So yeah, I mean, you can get there. You can tighten up the home to a point where, you can realize all the benefits of heat pump technology with it. Of course, if you have such a tight home, you need to have something to, remove the contaminants in it. That's where heat recovery ventilation units come into the picture. But that's for a different talk. Yes.
What's the payback period on that example you have?
Right. Yeah, that's coming up. So, coming to its energy consumption, it's about 11,000 kilowatt hours a year. At 16 cents a kilowatt hour, that's about $1,800 or so. And about $2.50 a gallon, that's about $2,500 of fuel consumption. So you're saving about $700 a year of electricity, or $700 a year of in the net. The difference between your oil consumption and your electric consumption. So let's say the heat pump costs about $7,500. I know this might be, the range is anywhere from $5,000 to $12,000. So let's say it's about $7,500. Apparently, there's about $900 worth of incentives. There's about $400 comes from Efficiency Vermont, another $100 from GMP, and apparently another $400 if you signed up, if you showed GMP the proof of purchase of the heat pump. So you have $900 of incentive. So your net cost is about $6,400. So you're saving around $700 a year. Net cost $6,400. So your payback is about 10 years. That makes sense? Great. So yeah. So I think we can, the brands and the makes. So there are quite a few installers of heat pumps. There are, and plus the brands Mitsubishi, Fujitsu, Daikin, Bosch. These are all available. And who installs them? Bennington Cooling Heating does. There are a few others out there who do. You can go to the Efficiency Vermont website. There are drop-down menus that you can use to find locally who installs them for you. So that's it. That's all I have. But if you have any questions, there's a lot more. I know that.
One comment Jim asked about the expansion valve.
Yeah.
Okay. The analogy I always use is when you get a can of Right Guard or any aerosol can, you have liquid under pressure. Okay. And when you depress the little button on this, it comes out like that and it evaporates. Okay. That happens inside the refrigeration system. However, in the evaporator, we capture that vapor and condense it and reuse it again. So it goes round and round. But it comes into that evaporator as a vapor, which allows it to evaporate.
Right. Mary.
In underground things, you had some that were blue and some that were red. Do some have heat and then it goes back in and it warms it back up again?
I think it's just showing pictorially that you have the hot refrigerant coming in.
Okay.
it's losing temperature on the ground and coming back in.
How
Or
much
vice
bigger
versa,
lawn do
depending
you
on if
have
it's
to
rooting
dig
or
up to
cooling.
do that? Would you like have to dig up your entire lawn?
Go ahead, George, all yours.
Well, the best way to go with any, in my opinion, is get a hold of an engineer and have them design, because your area that you need and the size of your house are all relative of what you need for a ground source heat pump. And they can design what you would need for your home, and then you'll have a better idea how.
In general, it looked big on that diagram. I don't know if that's.
Right, yeah, so there is a lot more that goes into doing ground source heat pumps. They are more expensive, definitely. Could be 2 to 3 times more expensive than conventional air source heat pumps. So, but they are more efficient. They're definitely more efficient. And if you have a big home, and if money is not a huge object to you, and you want to heat the home all year round and cool the home, this is the way to go. Yes?
This far north, I'm not seeing heat pumps work that well. Has that changed?
Yes. So, if you asked me 10 years ago about heat pump technology, I would have said, yeah, watch the space, it's coming there. But no, it's gotten dramatically better. Heat pumps now are a lot more efficient. That's why they're now marketed as cold climate heat pumps. And I think you folks can explain that in more detail, but they have got more efficient. They're able to turn down to lower temperatures and retain capacity. So that's why Efficiency Vermont is incentivizing them. That's one of our paths to a carbon-free future, really. Yeah.
I think back in the old days, when you're talking about, they used to have compressors that we used to call bang on, bang off.
Yeah, on-off machines,
And
yep,
now they have variable speed compressors. And
Right.
they just modulate.
exactly. Hey, go ahead.
You had mentioned that it could be used for both cooling and heating, and you showed the diagram.
Right.
Is the system just reversed for heating?
Basically, yeah. I mean, I think you guys can talk about that too, but yeah, what's an evaporator becomes a condenser and vice versa.
Now happens inside the system via a reversing valve.
I should speak to the fact that three of my sisters have mini splits.
Uh-huh.
Allowed them for air conditioning, but they use them in the spring and the fall for heat. You can turn off their furnaces. They didn't expect that, and they have no problem with them at all.
Yeah, you can use them all year round, and I do. I mean, there's no
And the
reason
other
to.
thing I wanted to ask was, could you use the ground system to heat up water for a floor heating system that's already in place?
Yes, isn't that? I mean, that's one of the ways that you can do the integrations.
Give you air conditioning.
It could go right into heating water.
Right.
Okay, thank you.
And is that technology available in this country now?
Yeah,
For the ground source heat pumps, yes.
but when you get into those, usually you have an engineer involved to design your sizes for what you want to do with your home.
I guess the biggest thing is if you're building a new home, that's the time to look at a ground source.
That's a great point. If you are building a new home, the incremental cost of installing, propane or oil-fired furnaces and all the ductwork or everything else, delta, the difference between that and doing a ground source heat pump, that's much narrower. So, people can easily, justify the added cost.
Do these wall ones that you're showing
Yep.
have the electric coils in them to supplement, because they won't take you down to 10 below?
Right, yeah. So that's essentially what they do. They do have a small electric resistance heater in them.
I had
As the
one for
temperature
9
drops.
years, and the electric bill, I had $600 bills at times, because it was totally running. When the weather's cold, you're heating with electric furnace.
Right, yeah, when it's very cold. Yes. And so, think about that. at the temperature transition where that occurs, it's usually around 5 degrees or so, 5 degrees F. So between 5 and minus 20, think about how many hours of the year you have. It's probably 200-300 hours a year, maybe more, I don't know, but roughly around that. If you look at the bins, the bin data for dry bulb temperatures, it's probably around 300-400 in that range. So it's not a huge amount of the time that you're very cold and that your system just becomes electric resistant speed. But those hours do add up to large electric bills. That's for sure.
But then you need a solar system to generate your electricity.
Thank you.
Oh, yeah.
Yes. Thank you for mentioning it. Somebody. Yes.
That solar panels and heat pumps is like.
The perfect combination. Yep. So yeah, I mean, that's the holy grail, really. That's how you can transition to a zero net home. You get an electric car, drive, install heat pumps, electrify your whole home, have a Nest thermostat, have everything on your iPhone app, and have solar, and bingo, that's it. As long as the sun's shining, you're good.
Okay.
You laugh, but
Could
it's
you
there.
stay
It's
around
coming.
for some-
Thank you.